Hello everyone and welcome. Today we are doing some A-level chemistry and I want to introduce you to alkene reactions. Now, there are a lot of these and you can't learn them all because there's just too many. There's thousands of these reactions that can take place and you could be asked a number of them. So instead of learning, what we need to do is find a strategy in order to cut down your learning. And rather than learn each specific reaction, what we're going to do is learn some rules. So today what I'm going to do is just introduce you to the way you look at these alkene reactions. The first thing we need to know about the alkene reactions is that they are double bonded and therefore unsaturated. What that means is you have a double bond which can then be opened up to allow more molecules to join. And so in A-level chemistry, you get this format here. Now, what sometimes helps is to actually write out our carbons. And this helps to figure out what's going on. As you get better and more comfortable with this, you won't have to write them out so every time, but just at the beginning, because when we were doing our GCSEs, we wrote in the hydrogen, and that helped us see where the hydrogens are and then how they react. Another important thing to note is that in these videos, I'll be referring to primary, secondary, tertiary, and quaternary carbons. What that means is how many carbons does the carbon attach to. So if we're looking at, I'll draw the carbon in question in purple. Now, if this carbon is only attached to one other carbon, then it is called a primary. If it's attached to two other carbons, secondary. And it's going to be called tertiary. And the final one, I'm not going to draw it, but that would be attached to four carbons, and that would be a quaternary. Identifying which is the primary carbon is important because our hydrogen often will join on to our primary carbon, but more about that later on. Okay, the first point was just that we had a double bonded carbon that can open up and allow other molecules. So it can break and we could allow, say, another two hydrogens on here. Okay, and so that it becomes saturated. Because the next thing we need to know is that this double bond is electron rich. So I'm going to draw another carbon alkene. Okay. And so this is 1, 2, 3, 4, 5 carbons. Double bond is on the second carbon. So this would be our double bond is electron. Because what is a bond? A bond is a paired electrons. So electrons bond in pairs. And so when you think of bonding, don't just think bond, and it's not an abstract thing. Think of a bond as electrons. And so when you see a double bond, you must think there's more electrons. Now, knowing this helps you to understand the mechanism of how these alkenes bond. So what happens is because the double bond is electron rich, it's going to, that negative is going to attack another bond. It's going to attack a polar molecule on the positive side because obviously opposites attract. So the third point then is that this double bond, so let's draw it. Let's just draw this double bond with the electrons. This is going to, and often you'll see the mechanism will be an arrow. And what it'll do is it'll attack a polar molecule. This double bond is going to attack the positive pole. And it's going to want to steal that H. Number 4 is it induces a pole in a non-polar molecule. So let's say we've got our alkene here. Now, what happens if I've got a non-polar molecule that doesn't have a positive side? Well, it's going to, remember these molecules are always moving. So say we had bromine gas. We've got bromine gas. So don't think of bromine gas just as Br2. Think of it as two Brs. Okay. So here's this Br gas molecule. I'm actually going to just draw a thing around it. So we can think of it as a molecule of two atoms. And in this molecule, you have a bunch of other electrons. So if this bromine molecule moves towards the double bonded, because to say you're bubbling bromine gas through an alkene, one of the sides of the bromine molecule is going to move closer to the double bond at some point. So one of the molecules, and obviously there's trillions of these. And so what's going to happen is like charges repel. The electrons are going to move to the other side of the molecule, and you're going to create a negative on the one side. And of course, if one side's negative, then because there's less electrons on the other side, this is going to now become a positive pole, which I've drawn there in green. And so because there's a positive pole, this now attracts the positive bromine, and so it's going to attack and it's going to steal this bromine first. And so when you have a non-polar molecule, you'll end up inducing polarity. And we'll see, we'll do an example of each of these to see how this all fits together when we answer a question. Now, the fifth point I want you to remember is that these reactions want to increase stability. So what happens when we see a reaction? Well, often there was an explosion in Beirut yesterday. We saw that massive mushroom cloud, and it was incredibly powerful reaction. That's chemistry happening in front of you. Now, if you go back to that site, what do you see? There's calm, right? There's destruction, but the reaction's finished because that reaction was seeking to increase stability. And so whenever you've got something that's unstable, it wants to become stable. Like when we look at our periodic table, our other molecules, they all want to aspire to be noble gases. And so that's why they react with one another to get the noble gas configuration. And so when we look at these alkene reactions, think of when you're looking at how something is going to end up in the end, think of what will be the most stable. And that is going to be your major product. So there's often two ways that a molecule can react, and you'll find maybe that 90% reach that more stable configuration, and then the other 10% react for whatever reason to become the slightly less stable configuration. So these reactions want to increase stability. Now I want to give an example of that now with just to continue with what happened with the bromine. So if I get given this question, and they say plus Br2. Okay, now this is 1, 2, 3 carbons, right? So 1, 2, 3. So monkeys eat peeled bananas is how I remember it. Monkeys eat peeled bananas. So monkeys 1, methane 1, ethane 2, peeled propane, and bananas 4. And so we are looking at a 3 carbon, so it's going to be propene. So this is propene and bromine. Bromine gas. Now, what I want to do is draw in the hydrogens and the carbons. Okay, it's double bonded. We've got an H here and an H here. And let's draw the bromine gas as well. Okay, so the first, the point about the number 4, inducing a polarity. So what happens? This bromine gas, the electrons all want to move to this side, away from the the electron dense double bond. So we have a negative pole here. And we have a positive pole here. Okay, so that's the first thing that the double bond does. Then it says, right, I've got something to attack, and I'm going to. So it attacks the bromine. It says, I'm going to steal you. So then what we would draw is an intermediate compound, which would be the C, but now it's gone and stolen the bromine. It's taken it. And so you'd have this bromine now joined on. Okay, I'm actually going to change this to, okay, so that would be if it was a bromine. I'm going to change this to an H. I'm going to change the bromine to a hydrogen. So this would have been something that wasn't attacked. It was already polar. So let's say that we had HBr. So HBr, say it was HBr, this would be no different now. The only thing is it doesn't have to induce a polarity anymore. It was already, we know that HBr is the hydrogen is always positive. So it attacks this hydrogen. And so this Br is actually an H. Okay, and here is what's important about stability. And we have an option of this one had another H here. We had an option of this HBr going, the H from the HBr going on the first or the second. So in other words, remember this was our primary, so I'm going to write down in a different color. I'll write it in pink. In number 1, so this was a primary carbon and this was a tertiary. So this is why I said we need to know the primary and and what they mean. Sorry, this was a secondary alcohol because it's attached to 2 carbons and this one's attached to 1. And so this stability point that I'm making is that the stability will decide where this H goes. It's not going to go on both of them. The H is going to go on one of them. And so you need to know, and so this is one of the rules you need to know, is that the most stable configuration would be for the H to attach to the primary carbon. So it's not going to attach to the, where we drew the Br. The H is going to attach to the primary. And so I'm going to erase this one, and I'm going to draw it here. Okay, so what happens is now this double bond is broken and it's attached an H to the primary carbon. And so because now an electron has gone to create this bond, you have a positive on the middle carbon. And so what's going to happen now is because the bromine was the negative pole, this now goes onto here. Okay, so what I'm highlighting in green would be the intermediate step. And we can then show that once this H has gone onto the primary, the bromine will go on. Why? Because there's now a positive and a negative. And so they're going to react to create a bit more stability. And so now you're going to end up with the final. I'm going to draw it at the bottom. And the Br. Okay, now this is a much more, now it's a saturated compound. It's more stable. And so this is the major product. Okay, so what do we do with this information? Well, what we want to do is we want to look at how to think about questions, because ultimately, if you're watching this video, probably studying for an exam or a test, and you want to be able to answer the questions. And you might be panicking because you've gone onto YouTube and you've seen there's a lot of these, there's thousands of these alkene reactions. You can't learn them all. So let's learn to think. Okay, how do we think about these reactions? Well, first of all, look at the reactant objectively and say, is this polar or non-polar? If it's an acid, it's going to be polar. So if you see sulfuric acid, H2SO4, HCl, you know that's polar. And what does the acid want to do? It wants to donate a proton. It wants to donate a hydrogen, usually. So the double bonded alkene is going to attack the hydrogen. And so if your molecule is polar, look for the positive pole. That's what's going to be attacked. It's going to take that positive pole and it's going to bring it into its molecule, like we saw with the HBr. Then what's going to happen is now, because it's the one side is attacked in H+, and now taking that hydrogen, the other carbon that was on the other side of the bond, that's now positive because it's needed electrons. It's taken some of its electrons and it's used them. Well, it's taken one of its electrons and it's used it to bond with that hydrogen, or the positive pole of whatever the reactant is. And so you end up, because that electron's gone over there, you've now got a positive on the other carbon. And that positive is now perfectly situated to now attract the negative of the polar molecule that was in question. So it first takes the H, the positive side, and then now the other positive then takes the negative side. And so we see that's happened with the HBr. Step one was it took the hydrogen because that was positive. And so we had the secondary alkyl carbon over here was now primed to take the negative bromine. And so the bromine slipped on there and we had this final molecule. And deciding whether the Br went on the middle or the side, that was when we looked at whether the stability is there. And so try and think about what's going to be the most stable. And this is where the most tricky part, and I'm going to do some more videos. So subscribe so that you get notifications on these videos, because I'm going to post videos on some of these reactions and you can use them as a template to understand other reactions which will be similar. So instead of learning 50 reactions, watching and probably not remembering because there's too many, let's learn about 5 or 6 and then to begin with, and those will be the ones that you can use as a template. And then you're just going to have to figure out, if you get something unusual, try and think of what is going to be the most stable. And then, you know, if you've got more time after that, then you can learn more and more reactions. But at least you'll be learning them with a greater understanding of these mechanisms and not just trying to memorize 500 different reactions, because that's a waste of time. So yeah, hopefully this helped you guys. I'm going to be posting. So if it did help you, like, subscribe, and all that good stuff. And I'll be posting more videos to help you with your organic chemistry. If you're doing mathematics, I'm going to be doing some videos on that as well. So enjoy the rest of your day and we'll see you soon.